Hello, everyone, and welcome again to another edition of Encora Talks. My name is Daniela Garcia, and I will be your host in this webinar. Our topic for today is creating a blockchain decentralized app, dApp. We have such an amazing speaker. His name is Rafael Zavala. Rafael is a full stack developer with a master's degree in computer science, specialized in AI and blockchain. He joined Encora as a React developer and is a member of Encora's blockchain community. Welcome, Rafael, and thank you so much for being with us today.
Hey, hello everybody. First, I want to say thank you to the Encora team that let me share this talk. And of course, thank you for being here. The topic that I will cover today has the title Creating a Blockchain Decentralized Application. And we will check a digital certificates use case. So I'm sure I will share my screen now. And okay, so there we are. So here's kind of my resume. I have been working for almost 6 years as a software developer. I have some experience on blockchain implementations, mainly using Ethereum smart contracts and React applications on projects like an electronic voting app, a company custom token, and the digital certificates project that I will talk more in depth about today. So first, I will make a quick introduction into the decentralized applications topic, covering some elements that might be helpful to understand what is going on when we are making the implementation. On the hands-on step, I will try to explain how the smart contract will be built on the use case, introducing some technologies like Solidity and the Truffle framework. And at the end, we will cover the main topic of this talk, some of the use case context, the smart contract that I made, and later we can check the API interface that I created to be used into a decentralized application. Okay, we will focus this talk on the hands-on experience of creating a decentralized application using smart contracts. But I want to take this part just to cover some of the main Ethereum smart contract concepts. First, I want to invite you guys to check the previous Encora talks related to blockchain and also check some of the articles that the blockchain community is uploading monthly to the Encora's blog. So let's get started. Okay, first let me talk about blockchain. The main concept is here. It is a public database that is updated and shared across many computers in a network. The word blockchain refers to the data and state being stored in consecutive groups, known as blocks, and the word chain refers to the fact that each block cryptographically references its parents. In other words, blocks get chained together. And yeah, we need to refresh this. Blockchain isn't the same as cryptocurrencies like Bitcoin or Ethereum. Blockchain instead is the mechanism or technology that cryptocurrencies use to provide integrity, protected data storage. Okay, so one aspect of blockchain that is gaining a lot of popularity are the smart contracts. Here, instead of just storing raw data on a blockchain like transaction details, we could store a contract, an actual agreement. This doesn't mean just a PDF document of a contract. Instead, they are mini computer programs with a predefined list of rules to control a business transaction. So what makes them smart is that once on the blockchain, it will be executed automatically based on those rules. Here, also any developer can create a smart contract and make it public to the network, using the blockchain as its data layer for a fee paid to the network. And any user can then call the smart contract to execute its code. Again, it is for a fee paid to the network. Okay. Let me just quickly introduce the concept of decentralized application. They are applications that are built on a decentralized network that combines a smart contract and a front-end user interface. When we talk about this kind of application, the most popular implementation is building a smart contract and deploying it to the Ethereum blockchain and create an user interface that connects to the contract functions. So let's go to the next step of the talk, that is creating our first smart contract. Okay, at this step, we're going to create a smart contract using the web IDE tool that is called Remix. First, I will try to explain some of the top features that it brings. Okay, it is an open source web application that is used for contract development with Solidity language, as well as a playground for learning and teaching Ethereum. Using this tool, we can deploy a contract on three types of environments: JavaScript virtual machine, injected Web3, and Web3 provider. The JavaScript virtual machine is convenient because it is a blockchain that runs on your browser and you don't need any other software or Ethereum node to run it. For performance purposes like a testing environment, it can be better to use an external node. And for smart contract testing, it is recommended to use the Ethereum testnets like Ropsten or Rinkeby. Okay, there are some links that we can use to understand how to create our first smart contract. First, the Ethereum documentation, Solidity language documentation, and the Crypto Zombie Solidity course. That is my recommended course on your first experience with Solidity. Okay, so let's jump to the hands-on part. On the first example, we will introducing the storage contract that is a sample provided by the Remix developer. It is the common sample to start working with Solidity smart contracts. So let's check this. Okay, so it has the Solidity language version to compile the contract. Then the contract name, that is storage. And then there is a variable that is number, that is an unsigned integer with 256 bits of size. Then there is the store function to save a value in the number variable that receives a param, that is a number, and store it on the number variable of the contract. And then there is the retrieve function, just to retrieve the saved value of the variable. Okay, so let's try to compile this at this section, and we click on compile. Okay, everything went good. So let's try to deploy it. Okay, we are using the Remix virtual machine, like I said, the JavaScript virtual machine that is in London. There are also another environments that we can check later. Okay. Then there are some accounts that are given by the virtual machine. We are just using the first one, and we are using the default values for gas limit and the value here. So let's try to deploy this. Now there is the contract compiled by Remix. Try to deploy it. Okay, everything went okay. And now on the deploy contract section, there is the storage contract. Okay, if we call the retrieve function, then the value would be a 0 because there isn't any value here. So there is the result, there is a 0. Okay, but if we call the store function with a value like a 10, for example, then we can call the store function and retrieve the function, and then there is 10. It is simple, right? So let's try it with another contract that is here for example, that is the MetaCoin contract. Okay, this is a more complex sample as this introduces more logic into the contract. Okay, it has the Solidity version to compile the contract code, then the contract name, that is MetaCoin. Then there is the balances mapping, that is a key value map structure that has an address and the amount. Then there is the transfer event that emits logs on smart contract calls. And this is logging the from, to, and value of the transfer transaction. Okay, then there is the constructor function of the smart contract that sets the balance of the creator to 10,000 coins, like this. And then there is the send coin function that sends an amount of coin to a receiver account, and it returns if the balance of the sender is sufficient for the transfer. Okay, here we are emitting the log event to when there is a transfer. Okay, and then the get balance function that retrieves the balance of an account on the balances mapping. So let's try to run this. Okay, we will compile the MetaCoin Solidity file. Okay, everything went good. So now if we check here, then there is the MetaCoin contract function. Again, we are using the first account. So let's try to deploy it. Now on the deploy contract sections, there is the storage and also the MetaCoin contract. Okay. Now let's try with the first account here. That is the owner, and it must have like 10,000 coins like the constructor is setting. Let's check this. Okay, there is the 10,000 value. Okay, now we can send some coins to the second one, for example, like this. The receiver would be the second one, and the amount could be maybe 1,000 using the first one. Okay, let's make this transaction. Okay, everything went good, like this. Now we can see if we are checking the logs, we can see here the input, the output that was sufficient was true, and the log event that has the from, to, and value of the transaction. Okay, now if we get the balance for the first one, it must be a 9,000, right? Okay, there is. And if we call with the second address, then it would be the 1,000. Okay, so this is running, right? Okay, so those are the first examples of working with Solidity. Okay. Okay, the digital certificates use case. To start talking about this project, let me introduce the tools that I used for developing that smart contract of the project. Okay, one of the tools was Truffle. It is the most popular development framework for Ethereum decentralized applications. The top features are smart contract management that we will focus today, automated contract testing, scriptable migration and deployment, network management, and a really nice interactive console. Another tool that we used was Express. It is a Node.js web application framework that we use to build the API interface to access the smart contract functions. One common way to work with Express and Truffle are the Truffle boxes. They are helpful boilerplates that allow the developer to focus on smart contract development. They can contain a lot of helpful modules, contracts, and libraries, as well as front-end views and more. The Truffle box that we use is Expressbox. Let's check how we can implement it into our case. Okay. So here is the Expressbox documentation page. And for the demo, we need to run each step. Okay, the Truffle Expressbox will provide the MetaCoin sample that we checked on Remix just to access an API that accesses the smart contract function that we can use for references for our case. Okay, so I already made these steps just to not wait on installation step, but let's check the documentation. It says that we need to install the Truffle and Ganache CLI globally, then download the box with this command here, and install all the Node modules required by Node. We can use npm or yarn if we prefer. And then we can start the Truffle development console using the Truffle develop command. And here we can compile, migrate, and test the smart contract code. And at the end, just to test the MetaCoin sample API, Then we just need to run the npm star or yarn star and check it on localhost. Okay, so let's check the code. Okay, I have opened this. I will open the metacoin construct. Okay, this is the same construct that we already checked on Remix. It has the Solidity version, the contract name, the balances mapping, the transfer event, the constructor function, and the sendCoin function, and the get balances function. It is the same. Okay, now we need to check the migrations. Migrations enable us to push the smart contract to the Ethereum blockchain, either local, testnet, or mainnet. We will use it to deploy the Metacoin smart contract code to our local environment. Okay, so the first migration just required the migration Solidity contract, and the second one would deploy the Metacoin contract like this. Okay, so let's check the server.js file now. Okay, it has the common JavaScript code that we use for Express web apps. Okay, there is that we are requiring Express and Web3 and body parser. But maybe we need to check the connection app file. Let's open it. Okay, so there is. Close this. Okay, at these files, we import the truffle contract module and Metacoin compiled version of the contract. Then we export a module that has three functions: the start, refresh balance, and send coin. Okay, let's see each. Okay, the start function that fetch the accounts of the Web3 instance that we are using. Just calling the get accounts from Web3 and retrieving that. Okay, then the refresh balance function that first get the deploy contract and call the get balance contract function with the account that is a parameter here, and just call the get balance contract function. Okay, and then the send coin function that first get the deploy contract, then triggers the send coin function, and then call the get balance contract function like this. Okay, so let's go back to the server file. There are some actions to the API that are get accounts, get balance, and send coin. That are calling the start function, the refresh balance function, using the account that is on the body of the call or the API call, and the send coin function that receives the amount, sender, and receiver, and calls the send coin function that is on the contract. Okay, so let's check how to run it. Okay, so there we are. Okay, I will close this. Okay, okay, there is the truffle develop. Just to open the command line of truffle. Let's wait a couple moments here. Okay, this is not related to the code. Okay, so it brings some account that we will use. We will be using the first one just. Now we can call the migrate function for the compile first. Compile. Okay, this is running like we are using on the Remix that we compile and then run the deployment with the migrate command here. Let's try. Okay, everything is up to date. There's nothing to compile because we compiled this already. Okay, well, I wait here. Okay, let me clear this. Okay, so everything was okay. It has the initial migration run, migrations, then the Metacoin deployment, and my another project deployment. So let's check here. migration. Okay, npm start, just to start checking it on localhost. Okay, okay, now it's listening. Let's check here. So if we get the accounts, I have these Postman APIs here. Now we get balance for the first one, and at the body I will use the first one here and send. It must have the 10,000 that we use on the constructor function of the contract. Then if we check the second one, it would be like this. It must have 0, right? Okay, so now it's a 0. Okay, so if we send some coin from the first one to the second one, we need to have the sender, that is the first one, then the receiver, that is the second one, and an amount. Check this. Okay, this is running. And if we check the balance for the first one, would be 5,000, and the second one would be 5,000 again. So this is running, and this code is really helpful to our use case. Okay, so okay, I'll go back to the presentation. Okay, so let's talk about the digital certificates use case that we use. This project was mainly focused on investigating blockchain features and applying it to a useful process inside my institute. Blockchain was a really new topic for me, so first I had to understand how the blockchain works. During the investigation, I had the opportunity to identify the types of blockchain, the challenges, and the consensus mechanism of each type. Another important challenge was just to justify the implementation of blockchain. So during this investigation, I set the task of investigating when blockchain is really an option. And like every project, we want to solve a problem or a need. So we identify a process where blockchain is useful inside my school. So here we identified that the institution was using a physical process storing certificates for the students that join extracurricular activities. So let's talk about what was this process. Here at the start of the semester, there was an activity selection phase where there was a group assignment of students and teachers. Okay, during the semester, the teacher instructs the activity to the students. At the end of the semester, there is an evaluation, and if there was a good evaluation, there was a signature of the head of the academic department of the activity. At the end, the student will keep the signed document that proves that he or she approves the activity. Okay, students must finish 5 extracurricular activities, so they have to make this process 5 times, which means that the student keep 5 physical documents. Then the students must validate those 5 documents at the Scholar Services Department. And at the end, there was the signature of a new document that releases students from extracurricular activities. Again, this was a physical document. Okay, so there is our idea. We was thinking like, hey, let's try to change physical certificates into digital certificates using the blockchain security features, as this is a common application of blockchain. So let's check the code that we made for it. Okay. Okay, I will close this and open the contract that I made. Okay. Okay, there is. So there is again the Solidity version that we have used, the contract name that is tech version 4. There was 3 version before it. Okay, the address of the owner of the contract, just to allow the contract owner to write on writer's mapping. Okay, the writer's mapping that stores the ID of the writers and the sign for them. The key was the sign hash with a 256 SHA algorithm, and the value was the user ID at the Firebase database. Then there is the writer size, that is just a counter, and the certificates mapping just to store the raw version of the certificate and the student ID. The key was the certificate string hash with the SHA-256 algorithm, and the value was the student ID at the Firebase database. Then there is the counter of the certificates, and we had these two events when we was testing it, that we are having a new writer and a new certificate. Okay, there is a modifier function that check if the transaction sender is the same as the contract owner. Okay, then there is the constructor function that says the owner address and initialize the counters to 0. Okay, then there is the new writer function that registers a new writer on the writer's mapping, receiving the writer sign and the user ID, and just storing it to the writer's mapping, adding the writer size +1, emitting the add sign event, and returning the new writer size. Okay, the validate writer function that validate a writer, checking its appearance on the writer's mapping, just a key, checking the key and the value on the writer's mapping like this. Okay, the new certificate function that add a new certificate to the certificates mapping. It receives the writer ID, the writer sign, the certificate, and the student ID. Okay, so here's we must check the writer that the writer is on the writer's mapping. If not, then we throw this error that is a non-authorized sign. Then we just add the certificate to the certificates mapping, emit the add certificate event, and just add 1 to the certificate size, returning it. Okay, so the validate certificate function that validate a certificate, checking its appearance again on the certificates mapping. Again, just checking that the certificate it's on the certificates mapping with the valid student ID that we are sending. And there is an auxiliary function that we use just to compare two strings with Solidity that is not common on this Solidity language. Okay, so on the migrations, we must add a new file that deploys this new contract. Okay, then we added like this. We was just like copy pasting this code to reuse this with this new file that was server tech before. Okay, and again it has the common JavaScript code to add a new Express web API. Okay, on the connections folder, I had this second app.js file. Okay, and here we are importing the truffle contract module and the tech before compiled version of the contract. Okay, and now we are exporting a module that has 5 functions: the start functions, new writer, validate writer, new certificate, and validate certificate. Again, the start function is just to fetch the accounts of the Web3 instance. Okay, the new writer function that gets the deploy contract and triggers the new writer contract function. Okay, then the validate writer that get the deploy instance of the contract and then call the validate writer function with the given writer sync and writer ID. Okay, the new certificate function that gets the deploy contract version and then triggers the new certificate contract function, sending the writer ID, the writer sign, the certificate, and the student ID parameters. Okay. Then the validate certificate function that gets the deploy contract and then call the validate certificate function of the contract. It has the student ID and the certificate. Okay, so let's go to the server before. Okay, so there is the get account function. That is a get that calls the start function of the app2.js file. Okay, the new writer function that receives the writer sign and the user ID that is stored on the database. And we are returning a message just to check if this was a successful or not, calling the new writer contract function, right? Okay, the validate writer that we are using the validate writer function, sending the writer sign and the writer ID that are on the body of the call. The new certificate that has on the body the writer ID, writer sign, certificate, and student ID, and passing it to the new certificate function to add a new certificate to the certificates mapping. And the validate certificate action that just checks the certificate and student ID and return if this is a valid or invalid one. Okay, so let's check the postman. Okay, no, I need to run this before go to postman. Node server. Okay, this now this is running on the localhost 3000 port. It's called the get accounts. It must be the same. Okay, yeah, these are the same. Okay, so let's call the new writer function. Maybe we can add like a user ID and a writer sign like this. Okay, it says that the transaction was successful. Okay, if we validate with wrong parameters, okay, it says that it is invalid. But if we call it with the right writer ID and the writer sign, it says that now it's valid. So this was called just to check that the writer of the new certificate was a valid one. Okay. Now we are creating a new certificate. Let's call it like this and this. Okay, the new certificate function was successful, and then there is the transaction ID. This is useful when we are using testnets just to check the transaction details. Okay, and then to validate a certificate that now is incorrect, it says that is invalid. But if we change this to a valid one, then there is a valid certificate. Okay, look like if we change something here, then it must be invalid, right? Okay, so this was the API interface that we use for the application that we built. Okay. Okay, so the results of this implementation. After the investigation, I have read a lot of articles and watched a lot of videos on how to implement blockchain. And I think I found that using Solidity and tools like Remix, Truffle, and Web3 was really interesting. With this project, the Express API that I built can be used by multiple mobile or web applications. I built a web application there, but there is a lot of projects that we can use with this API. And we identified that using blockchain, we can add security and traceability to this use case process. Also, now we can identify when to use blockchain and which blockchain implementation fits to each use case. Okay, and just to close this talk, I think blockchain is here to stay. And now we can see blockchain as a new technology, but I think in the future, the centralized and distributed system would be the regular systems. We will talk about blockchain as we are talking about the HTTP protocol or something that systems use regularly. So I want to invite you guys to start discovering the blockchain potential in your next projects and think about this as a future that brings security and traceability to any process. Uh, Now I want to thank you all for your attention. I hope that everything was clear. There is the GitHub link just to have the code reference of what I showed today. Now I'm open to any question that you have.